All right, today we are taking on linear relationships and we're writing linear equations. Okay, so first up, I'm saying write an equation for the line graphed below in slope-intercept form. So slope-intercept form is saying y equals mx plus b. M is our slope, b is our y-intercept. So when I look here, I see, oh, how nice, that's so thoughtful. Our y-intercept is a nice clear integer value at 0, 2. Okay, so here I know that the y-intercept is at 0, 2. And the slope, so if I pick 2 points, I'm counting down 1, 2, 3, 4, 5. So down 5 and right 2. So my slope, down 5, right 2. Negative 5 halves. So when I write my equation, I'm saying y equals negative 5 halves x plus 2. There's my slope, there's my y-intercept. All right, and I'm saying the same instruction for the next one. Write an equation for the line graphed below in slope-intercept form. The difference here, if you look right there, that's not a clear integer value. So I'm going to have to choose a different process for getting that, how to get to that y-intercept. So what we typically teach at Redwood is we have you guys start in slope-intercept form. So slope-intercept form would be like this. Y minus y1 equals m times x minus x1. So I have to know my slope and I have to know a point. And it doesn't matter which point we pick. I'll pick this one. So this point right here, if I count over 1, 2, 3, up 1, 2, 3, 4. So negative 3, 4 is this location. Negative 3, 4. That will be the point that I build off of. Okay, so x1, y1 will be negative 3, 4. Okay, and then the slope, here I'm going down 1, 2, and right 1, 2, 3, 4, 5. So my slope, down 2, right 5. So I'm going to go ahead and plug in. So y minus 4 equals negative 2/5 times x minus negative 3. So I've plugged into point slope. I knew a point, I knew my slope. I couldn't see the y-intercept clearly. Whenever I subtract a negative, that goes to a positive. So I'm just going to go ahead and make that a plus right there. And then I'm going to distribute that negative 2/5. So I have y minus 4 equals negative 2/5 x minus, well, I have 2/5 times 3. So I have 6/5 right now. I'm going to leave it like that, improper, for a moment. So now I need to add the 4 over, and I'm so close to being in slope-intercept form. So right now I have y equals negative 2/5 x, but I'm kind of stuck here because I have negative 6/5 plus 4. So if I make 4 in terms of fifths, I can multiply it by 5/5 and rewrite that as 20/5. So I have negative 6/5 plus 20/5. So if I combine those, they have a common denominator. I have 14/5. I could leave it like that. That would be perfectly fine. That's an improper fraction. I could also make it a mixed fraction. So an equivalent structure, I'd have y equals negative 2/5 x plus, well, 5 goes into 14 twice, so 2 times with 4 left over out of 5. So I could also write it just like that. So I could write it as 2 and 4/5. And if I go up and I look at it, does that look pretty close? Yes. I can see that it's in between the 2 and the 3, and it looks closer to the 3 than the 2. So I've done my job. I've written my equation in slope-intercept form. Okay, so next up, 3. Write an equation in slope-intercept form for a line with this slope that contains this point. So this skill is really just like problem 2. I just don't have a visual. So I need to start in slope-intercept form, point-slope form, and then convert it into slope-intercept form. So let me write out my 2 structures first. So here I have point-slope, and I want to convert it into slope-intercept form. Y equals mx plus b. So start point-slope, convert it to slope-intercept. So here is my slope, and here's my point. That's the x1, y1. So when I plug in, I have y minus 12 equals. My slope is negative 4/3 times x minus, my point here is negative 3. So negative 3. Now again, when I'm subtracting a negative, it goes to a positive, so plus right there. So now I need to distribute the negative 4/3. So y minus 12 is equal to negative 4/3 x minus. So negative 4/3 times 3, this is negative 4. Okay, and then I have to add the 12 over to the other side. And I'm going to end up with y equals negative 4/3 x plus 8. Okay, it is now in slope-intercept form. Okay, next up in 4, write an equation in slope-intercept form for a line containing these 2 points. So I want to do the same thing I did in 3, but I have to find my slope first. So find slope first. Okay, slope is always the change in y over the change in x. So I could label this x1, y1 and x2, y2. So change in y over the change in x. And the order we pull it, it doesn't matter. I usually do pull from the second point to the first. So if I do y2 minus y1, y2 minus y1, that will give me negative 5 minus 1. And then if I have x2 minus x1 on the bottom, that would give me negative 3 minus negative 7. Okay, so again, change in y, negative 5 minus 1. Change in x, negative 3 minus a negative 7. And when I subtract a negative, it goes to a positive. So I have negative 6 over 4, which is negative 3 over 2. So I have my slope. I just had to find it first. And now I'm going to go ahead and finish it up by going from, like I did here, point slope to slope-intercept form. And I can pick either point to build off of. It does not matter. I usually pick the first point. So if I plug in, I'm going to say y minus 1 equals negative 3/2 is my slope times x minus negative 7. Subtracting a negative goes to a positive. Distribute that negative 3/2. So y minus 1 equals negative 3/2 x minus. So negative 3/2 times 7. I know it's negative. So I have 21 over 2. 21/2. Okay, and then lastly, I need to add the 1 over to the other side. So I now have y equals negative 3/2 x. And now I have to figure out how to resolve this. So I have negative 21 over 2 plus 1. Well, if I create a common denominator, I'm going to multiply it by 2 over 2. Anything over itself is 1, so I'm not disrupting the ratio by multiplying by 1. So this would give me 2 over 2. So if I have a negative 21 over 2 plus 2 over 2, I still have a negative 19 over 2. So this would be perfectly fine, right? I'm just leaving that y-intercept improper, but I could also leave it as y equals 3/2 x minus 2 goes into 19, goes in 9 times with 1 left over out of 2. So I can also write it like this. That would be perfectly fine. We do always leave the slope as an improper fraction because it helps us to see the rise and the run. Either of these would be fine for the y-intercept. All right, problem 5. Draw a line parallel to the one provided, passing through 6, -5. So let me plot a point at 6, -5. So 1, 2, 3, 4, 5, and 6, and then -5. 1, 2, 3, 4, and 5. So there's the point that it wants me to create a line building off of that point parallel to the one on top. So this line on top, if I write its equation in slope-intercept form, y equals mx plus b, my slope, I'm going up 1 and right 3. So 1 over 3x. So y equals 1 over 3x, and the y-intercept 1, 2, 3, 4, and 5. So plus 5. So there's the first equation. And since I'm looking at parallel, that means I'm looking at the same slope. So parallel means same slope. So my slope for this second one has to be also 1/3. So I want to go up 1 and right 3. I can also go in the opposite direction, down 1, left 3. And that actually showed me where it crosses the y-axis. So I know my y-intercept, I can see it, just like so. So that second equation would be y equals 1/3 x. And then here I just count down 1, 2, 3, 4, 5, 6, and 7. Down 7. So remember that whenever we have parallel lines, they never intersect because they have the same slope. Okay, problem 6. Draw a line perpendicular to the one provided, passing through -1, 4. So -1, 4 is right here. So we want a line that's perpendicular to this one passing through that point. So remember first off that with perpendicular, our slopes are opposite reciprocals. Okay, and slopes, when they're opposite reciprocals, that just means that you're taking the fraction and you're flipping it. If I have a reciprocal would be 4/5 to 5/4, right? You're taking something and flipping it. So reciprocal, you're just flipping a fraction. Opposite means opposite sign. So we want the opposite sign and we want the fraction flipped. But again, that language of reciprocal, you're just taking a fraction and you are flipping what's in the numerator and denominator positions. Okay, so first off, this line that's graphed, my slope, I've gone up 1 and right 2. So my slope is 1/2. So y equals 1/2 of x. And here my y-intercept, I was going up 1 and right 2. So that is 1/2. So here if I just count up, 1, 2, 3, 4.5. And if you didn't see that so clearly, you could do it from going point slope to slope intercept as well. Okay, so I want, let's see, I want a perpendicular line to this one, and I want it passing through -1, 4. So that means that my new line will have to have a slope that is the opposite sign, so it has to be negative, and the fraction here gets flipped. So 1/2 becomes 2/1, which is really just 2. So right now I know y equals -2x. So from this point, I'm going to go down to right 1, down to right 1, down to right 1, just like so. And then when I connect my dots, I have a perpendicular line. I know that perpendicular means it creates that right angle. All of these angles would be right angles. They'd be 90 degrees. So I can see that, for example, if this is my center of rotation, this point has rotated 90 degrees to become that point right there. So lastly, I just need to find my y-intercept, and I can see that it's right here at 2. So plus 2. So here I have two lines. They are perpendicular. Their slopes are opposite sign and reciprocal. They have different y-intercepts. All right, next in problem 7, write the equation of a line with an undefined slope that contains 6, -2. So undefined, how do we get that? Well, we get that when it's a vertical line. So vertical lines have slopes that are undefined. So when I'm calculating slope, that means that I must have had a number on top with 0 on the bottom, which makes it undefined. So just a little reminder as to where that comes from. So right away, I know that its slope is undefined. It's a vertical line. What does a vertical line always look like? X equals a constant, always. X equals a constant. So that means that if I have a line that's passing through this point, well, it has to be x equals 6, right? Because it has to share this x value in common. So I know right away x equals 6. But sometimes it's nice to have a visual approach. So if I make myself a little coordinate plane, and I plot a point that's roughly at 6, -2, so let's just say right about here, that's at 6, -2, and I'm trying to picture what would be the line that would have an undefined slope, it would have to be this one, which then just confirms that it shares that x value, x equals 6. Okay, if I had given you a slope that was 0 instead, so a slope of 0 means it's a horizontal line, and it would have been y equals a constant instead. Okay, one more problem. 8. All right, write an equation in slope-intercept form for the line containing -8, 4, and perpendicular to this one right here. So here, it's really the same skill as problem 6. It's just not giving you a visual. So here we have to build off of our knowledge of opposite reciprocals. So we know that perpendicular means that the slopes are opposite reciprocals. So opposite sign, fraction flipped. So if I take that -2, I'm going to make it positive, flip it, becomes 1/2. So my new slope will be 1/2. And then I'm given a point right here, it contains this point, and now I know what the slope is, 1/2. So I'm going to go point slope to slope-intercept form. So y minus 4 equals 1/2 parentheses x minus -8. When I subtract a negative, it goes to a positive. And then I have to distribute the 1/2. So y minus 4 equals 1/2 of x plus 1/2 of 8 is 4. Okay, and then I have to add the 4 over to the other side. And I end up with y equals 1/2 of x plus 8. And that would be my final answer. This line will be perpendicular to this line. Okay, and I know that because they are opposite reciprocals for their slopes. All right, that's all I have for today. Enjoy the rest of your day.